Okay, so 3-2 starts out with the definition there of a radian. So a radian is when the arc length of a circle is equal to the radius of that circle. So the arc length, remember, is a piece of the circumference. It's a part on the outside of the circle. So when that piece on the outside of the circle is equal to the radius, we get what's called a radian. Okay? Now, how do we find radians? Well, we call them theta. It's an angle, but instead of being in degrees, we put a rad. He's a super rad dude from the 80s, right? And it's equal to S divided by R. When those guys are equal, it equals 1. Because S is the arc length. And R is the radius. Okay, now, number 1 there says, a central angle of theta in a circle of radius 3 cuts off an arc length of 6 centimeters. What is the radian measure of theta? Okay, well, let's just use our formula, right? Theta is equal to, my arc length is 6, divided by my radius, which is 3, so that guy is 2 radians, or 2 rad is how we write them. Think about, you've got to label your units, right? When we talk about degrees, we give them a degree symbol. When we're talking about radians, we have to write rad, or you can write out the word radians if you want. Okay, so the angle from 1 full rotation will equal the arc length of the circumference of a circle. Okay, let's think about that for a second. The angle from 1 full rotation, if I go the whole way around the circle, 360 degrees, will equal the arc length of the circumference of that circle, right? The circumference is the same as the arc length in that plane. Okay, so what that's saying, here's my formula. If I take 2 pi r, that's the circumference. Would you agree with that? And I divide it by my radius, which is r. What happens to those r's? They cancel, and I'm left with 2 pi. So if I go 1 full rotation around the circle, 360 degrees is the same as 2 pi radians. Would you agree with that? Yeah. You see where that comes from? Let me write it here. 360 degrees equals 2 pi radians. So 1 pi radian, half of a circle, is equal to 180 degrees. Okay, now I can solve this equation right here for either 1 radian or 1 degree. So 1 degree, that's a degree symbol there, is equal to pi divided by 180 degrees. Or 1 radian is equal to 180 degrees divided by pi. I would put a box around both of those bad boys. And you're going to say, why do I have to know another unit of measurement, right? Why does it matter? Can't we just keep everything in degrees? Well, in days gone by, if we would get to chapter 4, which we're not going to, you'll do it in pre-calc, but we take these trig functions and we graph them on the coordinate plane. So I'm going to take all of the trig functions for sine and I'm going to graph it on the coordinate plane. If I do that and I go one rotation around my circle, I have to go from 0 to 360 on my x-axis, right? But if I do it in radians, a full rotation is only 2 pi. Well, what's pi? Give me an approximation for pi. 3.14. So 2 of them is like 6.28. Would you rather graph on a scale from 0 to 360 out in La La Land or from 0 to 6.28? That sounds better, right? So think about it. It gives us a different unit of measurement that condenses things. Kind of think about it as like feet and inches, right? I don't want to measure everything in inches if I could go to feet sometimes. Does that make sense? So like I said, radians just gives us a different unit of measurement. And they're more smaller or concise, if you will. Does that make sense? Okay, so the first one there says convert 45 degrees to radians. Okay, well 1 degree is pi over 180, so I want 45 of those. So 45 times pi over 180. Now the thing with radians, if he's got a pi in it, we're going to keep that pi. So this guy has a pi and I'm going to keep him in my numerator. Now 45 and 180, remember that's a fraction. Oh, hey, that's fun to read. This thing must have been like, you've used me too long in its life. Like it's ready for summer or something because it is being super naughty. And then it takes its sweet time to focus. It's like a teenager. Okay, so when I multiply this guy straight across, remember I get 45 times pi over 1 times 180. Now let's reduce that. Oh, that was a tricky thing on your test. I had lots of people that didn't reduce their fractions. Like 8 over 2. Come on, friends, that's 4. 2 over 8. Tricky, it's 1/4, right? If you're not sure, your calculator does reduce fractions for you. Green, y equals 45 over, don't put the pi in there because it doesn't know what to do with pi, right? It won't give you a decimal. So 45 over 180 reduces to 1 over 4. So this is 1 pi over 4, or just pi over 4. Like I said, don't put the pi in your calculator. China.
Do you want us to mark it with unit every line?
So when it's doing these ones and it says convert, I'll assume that you're doing it, so not necessarily. When you're labeling it like on your answer, you'll want to, because we could also end up with something that's like 2 degrees, so just be careful. Harry.
How did you fit on the calculator? How did you do that?
How do I get the fraction thingy?
Yeah.
Hit the green alpha button, and then hit y equals. Do you get a menu that pops up like that?
Yeah.
So the first one just says numerator over denominator, so you can just grab that bad boy. Did that help?
Yes.
Okay, perfect. Okay, so let's try 450 degrees to radians. Okay, so I want to take 450 times pi over 180. Or 450 pi divided by 180, reduce that bad boy as my fraction. We should get an improper fraction this time, right? Because 450 is more than one way around the circle.
So you're plugging the pi?
No, don't put the pi in.
Don't put, so just do the.
I just do the numbers. I just do 45, 450, and 180. He'll give you a crazy decimal if you put the pi in. 5 pi over 2. Okay, well, let's try the other way. So number 4 and number 5 say convert from radians, pi over 6, to degrees. Now, everything we've done up to this point, right? I haven't given you, like, pi degrees, if you will. So what I want to do is I want to get rid of that pi in the numerator. Which means I want to flip this guy right here. So 1 radian is 180 over pi. So pi over 6 radians will be times 180 over pi. Pi's cancel, right? I got a pi in the top and a pi in the bottom. So 180 divided by 6 is 30 degrees. So this one we should label with the degree symbol. Okay, 4 pi over 3. So I'm going to take 4 pi over 3 and multiply it by 180 over pi. Again, the pi's will cancel. 4 times 180 all over 3. Make it work for you. Whoop, sorry. 240 degrees. Okay, are you okay going back and forth? Okay. Then it says, get acquainted with table 1 on page 140. Alright, so let me show you table 1 on page 140. There's 2 things, I think, on page 140 that are really useful. The first thing is figure 12 here. And let me see if I can make this thing zoom in so you can see it. We'll talk about this next week, but this guy right here is the beginnings of our unit circle. It's taken the degrees and converted them to radians the whole way around the circle. That's pretty cool, right? So that you can look and say, okay, 150 degrees is 5 pi over 6. See that? That's the first thing. The next thing is it's taken our exact value chart. This one is the table 1 here. Hold on, let me zoom out a little bit. Come on. It's taken it and taken our exact value chart. It's flipped it sideways. So thanks, friend. But it's done it in degrees and in radians. So 30 degrees is equal to pi over 6, and there's your 3 trig functions for sine, cosine, and tangent with their exact values. Okay, so that's kind of cool. So if you don't have your exact value chart, you can find it on page 140. It also goes a little bit past it. It goes to 180, 270, and 360. Remember, the other ones we can find with our reference angles, just like we did. Okie dokie? All right, so let's keep that in mind, and let's see what number 6 here says. Number 6 says find 4 times the sine of 7 pi over 6. Well, I don't know about you, but 7 pi over 6 sounds a little foreign to me. Does it sound foreign to you too? Okay, so let's see if we can find 4 pi over 6 on this guy right here, because I think if we put him in degrees, it might make a little more sense to you. Would you agree?
I concur.
Okay, so find 7 pi over 6 on our little circle here. 210 degrees. Okay. So 4 pi over 6 is, or 7 pi over 6, excuse me, is the same as 4 times the sine of 210 degrees. Okay, but now I don't have 210 on my chart. So we gotta find our reference angle. What quadrant am I in? 3. I'm in quadrant 3. Okay, so in quadrant 3, sine is negative. I gotta zoom out. And what's my reference angle? 210 minus 180. 30 degrees. So the sine, 4 times the sine of 210 is equal to the negative 4 times the sine of positive 30. Exact value chart either in your book
Mathematica.
is 1/2. So negative 4 times 1/2 is negative 2. There we go. Okay, you okay with that? Questions on that? Take that circle thingy there, and we'll make one of our own next time. But change that radian into degree measure. You can also change it 7 pi over 6 if you don't have that by multiplying by 180 over pi. Does that make sense? Okay, number 7 here. Evaluate 4 times the sine of 2x plus pi when x equals pi over 6. Wondering. Here we go. 4 times the sine of 2 times pi over 6 plus pi. How about this dude right here? What happens to this guy? 2 pi over 6, which reduces to pi over 3. Okay, so this is sine 4 times the sine of pi over 3 plus pi. To give that guy over 3, right? We need a common denominator. Okay, so if I put a 3 in the bottom, I'll get a 3 in the top. Okay, so this guy is 4 times the sine of 1 pi over 3 plus 3 pi's over 3 is 4 pi's over 3. Okay, 4 pi's over 3's. Either convert it with your formula, 4 pi over 3. You see him? 240, right? Okay. We're still in quadrant 3 like the last one. So we know sine is negative. So my reference angle is 240 minus 180 or 60. So this guy is equal to negative 4 times the sine of 60. Exact value chart, negative 4 times root 3 over 2. Negative 4 root 3 over 2, and again we know how to reduce fractions. So negative 2 root 3 over 1 if you like, or just negative 2 root 3. Okay, questions on any of that?